Now that we've created our grouped frequency distribution, we can use that to create something known as a frequency polygon, which is a very nice way of visualizing our distribution. So in order to construct this frequency polygon, however, you need to compute the midpoint of every single one of your classes. So the way you go about computing the midpoint is actually fairly easy. So what you're going to do is you're going to take the lower limit and the upper limit for each class, and you're going to average them together. In other words, you're going to add them together and divide them by 2. So the midpoint of the very first class is going to be 0 plus 13 divided by 2, which gives us 6.5. The midpoint of the second class is going to be 14 plus 27 divided by 2. So we get 14 plus 27 divided by 2, which gives us 20.5. And we can keep doing that for every single one of our classes, averaging the lower class limit and the upper class limit to get the midpoint of each one of our classes. Perhaps an easier way of doing this, though, is to simply take the midpoint that you've already computed of the previous class and then add 14 to that, which is the class width. So if we take the class width and we add that to the midpoint of the previous class, we're going to get the midpoint for the current class as well. So if we take 20.5 and we add to that 14, we're going to get 34.5, which is the midpoint of the third class. The midpoint of the fourth class is going to be 34.5 plus 14, which gives us 48.5. And we can continue this pattern to get 62.5, 76.5, and 90.5. So we've now computed the midpoint of each one of our 7 classes. We want to use that to create our frequency polygon. So what I'm going to do here is I'm going to transfer this information that we've already computed onto this slide right here where we're going to construct our frequency polygon. So now let's talk about how to use this information to construct our frequency polygon. So on the y-axis, what we want to do is we want to create a scale that corresponds to the frequency of our grouped frequency distribution. You can see that the largest frequency value is 14, so my y-axis needs to extend at least up to 14. And so what I've done here is I've created tick marks in increments of 2 that correspond to frequencies of 2, 4, 6, all the way up to 14. And on the x-axis here, I'm going to draw tick marks that correspond to the different class midpoints. So I have a tick mark for 6.5, a tick mark for 20.5, a tick mark for 34.5, and I keep that same pattern until I get a tick mark also for 90.5. So once I've created the y-axis scale and the x-axis scale, I can now start placing dots that correspond to the midpoint and frequencies of each one of the classes. So what I want to do here is I want to place a dot that corresponds to a midpoint of 6.5 and a frequency of 14. So that would be right about there. The next dot I want to place corresponds to a midpoint of 20.5 and a frequency of 9. That's going to correspond to a dot right about there. The next dot is going to have a midpoint of 34.5 and a frequency of 5, which corresponds to a dot around there. The next 3 dots have midpoints of 48.5, 62.5, and 76.5, but the same frequency of 1. So I'm going to put 3 dots in a row at a midpoint of 48.5, 62.5, and 76.5. And lastly, I want to place a dot that corresponds to a midpoint of 90.5 and a frequency of 2, which is about right there. Another small detail that I need to remember when I'm creating my frequency polygon is that essentially I want to add 2 additional midpoints before the first class and after the last class so that I can get my frequency polygon back to 0. And so after we've computed all these midpoints, I actually need to add 2 additional midpoints for hypothetical classes that we didn't observe. And so what we need to do here is we need to subtract the width, the class width, which if you remember from before was 14. I'm going to take that class width, I'm going to subtract it from the first midpoint. So 6.5 minus 14 equals negative 7.5. And since that class doesn't exist, it has a frequency of 0. And for our last midpoint was 90.5, and to get the next hypothetical midpoint, I'm going to add the class width to 90.5. So the next hypothetical class midpoint would be 90.5 plus 14, which gives us 104.5. And since we didn't even observe any data in that class, that frequency is 0. And so now that I've added this midpoint before the first actual class and a midpoint in a class after the second actual class, I'm now going to place dots that correspond to a midpoint of negative 7.5 and 0 and a midpoint of 104.5 and 0. And so you can see I've already actually put the tick marks here, tick marks on my x-axis. So I'll notate that here. So this is negative 7.5, this is 104.5, and the dots for each one of those midpoints, the frequency for each one of those midpoints corresponds to 0. And so once I've placed all the dots that correspond to all the midpoints and frequencies, I'm simply going to connect the dots using a straight line, or at least as straight as possible. And so I keep doing this until I get back to the x-axis, which corresponds to a frequency of 0. So now that I've drawn my frequency polygon, I want to try to interpret it. And so what I'm usually looking for here is I'm looking for where the frequency polygon is tall. I want to know whether it extends out far in one direction or another. So because it's tall right here, it means that values close to 6.5 are more likely than values that have larger values. Okay, so because we have a big peak here, it means that it's more likely to see a value that's smaller, that's close to 6.5. And because I have a long tail here, so because it gets really short but then kind of extends out, this would actually mean that the data are positively skewed, which means that the bulk of the data tend to be small, but then there are a few large observations as well.